The vectors p and q are such that p is 11i minus 24j and q is 2i plus alpha j. We want to find the value of each of the constants alpha and beta such that p plus 2q is alpha plus beta I minus 20j. So the vector p as a column vector is 11, negative 24. And if we want 2 q's, that's going to be 4 and 2 alpha. So what we have is 15 and 2 alpha minus 24. So comparing the j components, we can see that 2 alpha minus 24 is negative 20, giving us that 2 alpha is equal to 4, and therefore alpha is equal to 2. And if we look at the I components, we get 15 is equal to alpha plus beta, and if alpha is 2, that means that beta must be 13. And using the values of alpha and beta now from part 1, find the unit vector in the direction p plus 2q. Well, p plus 2q, we've just established, is 15, negative 20. So the modulus of that would be the square root of 15 squared plus 20 squared. So if we've got 15 squared, add 20 squared, I know it's going to be 625 before I started typing it in. 625, so square root that is 25. Nope. It's because I put answer in there twice, so it's 25. So the unit vector would be 1 over 25, 15, negative 20, and of course we can do a bit of cancelling here and make it 1 over 5, 3, negative 4. You've probably gathered I'm not a big fan of the I's and J's, but probably if I was doing the exam I would write it p plus 2q, it's going to be awkward to write it like that, but I would probably write my answer as 1/5 3i minus 4j, just to put the answer back in the form in which it was given. I don't like working with i's and j's very much. So this question actually goes on further, but I don't know if it relates back. So the points A and B have position vectors A and B as shown in the diagram. And we can see that OA is A and OB is B. And AB to AB, AC is 1 to lambda, which is another way of saying that AC is equal to lambda AB. Find an expression for OC in terms of A, B, and lambda. Well, to go from O to C, what we could do is go from O to A, and then go from A to C. So O to A is A, and then A to C, as we just discussed, is lambda AB. And how would we get from A to B? So A to B would be backwards along A, forwards along B. So that's minus A plus B. So that is going to be A minus lambda A plus lambda B, which is 1 minus lambda A plus lambda B. The points S and T have position vectors S and T with respect to an origin O. The points O, S and T do not lie in a straight line. Now that's important because it means these vectors S and T, they're not parallel. But we're given that the vector 2s plus mu t is parallel to this vector, and we want to find the value of mu. Well, if they're parallel, 2s plus mu t must be some constant multiplied by mu plus 3s plus 9t. And then we can equate the s's. So if we look at the s's, we get k mu plus 3 must be equal to 2. Let's call that equation 1. And if we look at the t's, that gives us that mu is equal to 9k. Let's call that 2. And what I'm going to do is I'm going to sub 2 in 1. And then I'll have k, 9k plus 3 is equal to 2. So that's 9k squared plus 3k, take away 2 equals 0. And I think we can factorize this. Pretty sure we can. 3k and 3k, 2 and 1. And if we have this one as a plus and this one as a minus, that gives us that k is equal to negative 2/3, or k is 1/3. And this one here is not possible, and let's just point out why. It tells us mu is a positive constant here, and mu is equal to 9k. So if we had that value, mu would be negative. So k is a third, and so 2 gives us that mu is equal to 9 multiplied by a third, which is 3.